Hey, welcome back. In our last video, we learned how to design our medallion here using Autodesk Inventor. In this video, we're going to learn how to machine our medallion here using Autodesk HSM. To get started, go ahead and click on the CAM tab, and we're going to start a new setup. The first thing we need to do now is to set up our work coordinate system, our WCS here. And it is always customary to use this back left corner, so we're going to go ahead and click there. All right, and make sure your positive X is, if you're facing your part here, your medallion, positive X is pointed to the right, positive Y is going away from us, and positive Z is pointing upwards. If you need help getting this set up, please let me know. All right, and now we need to set up our stock size, and we're going to come on over here, we're going to select fixed size box. For X, we're going to go ahead and use 3 inches. For depth, we're going to use 3.4 inches. And then for Z, we're going to use 0.375 or 3/8 of an inch. And we are going to offset that from positive Z a distance of 0.01 inches. Okay, that should do it for our first setup. Go ahead and hit OK. And the first operation we want to perform is a facing operation. So up here, go ahead and click face. This will give our medallion a nice polished surface and a nice flat surface. So we're going to come on over here to tool, and we're going to load you should have installed the medallion tool library there, and we're going to select our 3-inch facing mill and hit select. Okay, and this time we're going to leave our coolant on, and hopefully that'll help create a nice smoother a better surface finish. So we're going to turn our coolant and we're going to set it to flood here. We're going to use a spindle speed here of 4,000 RPMs, and we're going to use a feed rate here of 20. All right. And now for our geometry tab, we are going to select this. Make sure you get this top surface too in the whole medallion here. Okay. And then over here under our passes tab, we're going to use a pass extension here of 1 inch and a stock offset value of 1 inch as well. Okay, all the other default values look good. Let's go ahead now and hit OK. And we should have hopefully gotten a toolpath that looks just like this. All right, now we need to move on to our next operation, and we're going to start engraving our logo here on our medallion. And to do that, we're going to do a 2D milling operation, and we're going to select trace here. All right, we're going to, for our tool here, let's come to our tool library, go to medallion. We're going to select our 6.25 millimeter 30-degree chamfer tool and hit select. Like I said, leave our coolant to flood, and we're going to use a spindle speed of 3,000 and a feed rate of 20 inches per minute. Okay, and for our geometry tab now, here's where it's going to get a little tricky. All right, so for our geometry now, we need to basically select everything that we want to engrave. So our border, our text, our decorative feature here, and don't forget this guy right up here. All right, and then you need to go in and select our tiger logo here, and it's going to take a while, and you're just going to need to click on every single line the best you can. Okay, I'm going to do this. It's going to take me a while, so in the interest of saving time, why don't you guys go ahead now and do this. Click on every single line, and when you're done, okay, go ahead now and pause this video, and when you're done, come back and you can see what it looks like. Okay, and when you're all finished, you should end up with something that looks like this. Everything you want to engrave should be blue. So please double check, make sure you've clicked on the inside of your R's, the inside of your O's, the top of our decorative feature here. So please look it over and double check everything. All right, moving on. We're going to come over to our passes tab now, and we are going to select an axial offset. This is how deep our tool is going to engrave. And it's not going to really engrave this deep because we're using a spring-loaded tool. Okay, but I want you to enter a value of minus 0.05 inches for our axial offset. Check smoothing to simplify our G code and go ahead and hit OK. Now let's go ahead and simulate our setup here. So click on your setup and we're going to simulate this. I'm going to skip past my facing operation here. And if you look at our engraving, it's actually, you're like, wow, that looks like a really wide, deep cut. And it is. And that's because we set our depth as a really deep cut. But remember, we're using a spring-loaded tool. It's really not going to look like this. In reality, I can show you real quick. Let's go to our trace and edit that guy, and we're going to change our axial offset now. So in reality, our depth of cut is really more like minus 0.01. And we can go ahead now and simulate that guy just to show you. So in reality, our engraving is going to look like this. Okay, like I said, we're using a spring-loaded tool, and we're doing that mainly because with the spring-loaded tool, we can get away with a feed rate of 20 inches per minute. Without a spring-loaded tool, we'd be engraving right here at about 5 inches per minute. So it saves us a tremendous amount of time. All right, so let's go back now, and please make sure your axial offset here is set to minus 0.05 there. Okay, and I'm going to go ahead now and hit OK, and that's what we want. All right, so now we want to go ahead and remove the material around the perimeter of our medallion. And to do that, we're going to use a 2D adaptive. All right, and we're going to grab our tool library, and we're going to be using a 1/2 inch flat end mill. Okay, carbide tool. We're going to set our coolant to flood. We're going to set our spindle speed now to 5,500. And we're going to use our feed rate here of 40. Okay. And then for our geometry tab, all right, we want to click the bottom perimeter. I'm going to kind of move it around here so you can see that. Don't get the inside of it. We want to click that right there. Make sure you don't get that inside part. All right. So you should have something like that. Moving over to our passes tab now. This is a roughing operation. So to remind you, we want to use an optimal load of 0.1 inches. That'll give us about a 20% tool engagement with material. And we're going to go ahead now and check stock to leave because this is a roughing operation. So we're going to leave radial stock, okay, stock along the walls of 0.01, and we're going to leave no stock along the bottom. We're just going to set that to 0 inches, okay. And go ahead and check smoothing, and we're just going to go ahead now and hit OK. And if you did everything right, you should end up with a tool path like this. Okay, so our next operation, we're going to remove the material in our medallion loop here, or this small little pocket. So we're going to come on up here and just select 2D pocket. We're going to grab a different tool. We're going to go to our medallion here, and we're going to select a 1/8 2 flute end mill. And we're using a 2 flute because it's a small pocket and it will allow for more chips to evacuate out of there. So we're going to hit select. We're going to set our coolant to flood. Okay. And then for our spindle speed, we're going to go ahead and use 5,000 RPMs. Okay. And a feed rate of 20. And we're going to use a plunge feed rate here of 9 inches per minute. Okay. And then for our geometry tab, we got to come in here and click this inner circle here, the bottom of it. Okay. And then now moving on over to our passes tab, we're going to come on down here and we're going to make sure you check stock to leave. And once again, we're going to leave radial stock along the walls of 0.01, and we're going to leave axial stock of 0. Okay. And over here in our linking tab, we're going to set our ramping angle here to 3 degrees. Okay, go ahead and hit OK. And if you did everything right, you should end up with a tool path that looks something like that. Okay. All right, so our roughing passes are done. We need to go ahead now and do some finishing passes. So we're going to come on up here, and finishing passes are traditionally done with our 2D contour operation. So go ahead and click on that. We're going to stick with our 1/8 flat end mill. Okay, we're going to make sure our coolant's on. We're going to slow it down now, and we're going to use a spindle speed of 3,000 and a feed rate of 20 here. Okay, in our geometry tab, remember we got to remove that stock along the outside here, and we left a little bit along the inner walls here as well. So we want to remove that part right there. Okay, and in the height tab, we're going to set our bottom height here, and we're going to set our bottom height so that we're going to go ahead now and we're just going to select there, and we're going to offset it minus 0.01 inches here. So our tool will cut just a hair below our part. In this way, so when we go to face off that material, like I said, we'll get a nice clean detachment here. Okay, and that should do it. When you're done with your bottom height here, go ahead and hit OK. And you should have a finishing path that looks something like that. All right, and that does it for our first setup. Now let's go ahead and start our second setup. All right, so to do that, let's flip our part over. And so we're gonna have material here, the hat portion. We gotta face off that remaining material here on the other side. So let's go ahead, start a new setup. Okay, and orient, orientate your part so it looks something like this. We're gonna click on the back corner here. And if you notice here, our X, Y, and Z coordinate system is incorrect. So I'm gonna click my Z and that'll flip it, and then I'm going to flip my Y, and here we go. Looks good. So make sure you're using that back left corner. Positive X is going to the right, and positive Y is going away from us, and positive Z is pointed up. Okay, on to our stock size. We're going to go with fixed size box, and our X is going to be 3 inches. Our Y is going to be 3.4 inches. Make sure they're both center. And our Z here is going to be 0.365 inches. Remember, we removed 0.01 inches from our facing operation, so it's a little bit thinner. Okay, and now this looks pretty good, but we need to offset this from Z minus a distance of 0 inches. Okay, so basically now you have something that looks like this. Okay, let's go ahead and hit OK. All right, so instead of just going with a straight facing operation this time, we have an issue that we have to deal with. And the issue stems from the fact that you have to remember that we have a big plate of stock material left on this part here. And we have these corners here sticking out. So rather than doing a facing operation, we're gonna do what's called a 2D adaptive in this case. And the reason is because when you're facing off, if you're just gonna do a facing operation, you have these big edges that protrude out, and when you're facing them off, it can be bad because you have large chunks of metal that can shoot off and potentially damage your machine, your probe, or hurt somebody. So it's better to come around the sides and remove these corners with a 2D adaptive operation and then face it off. So to do this, let's go ahead now and do a 2D adaptive operation. We're not going to use a 1/8, so we need to go reference our tool library again. So let's go to our Medallion tool library, and we're going to get our 1/2" flat end mill, 3 flute. Go ahead and hit select. We're going to use a spindle speed of RPMs of 5,500, and we're going to use a feed rate of 50 inches per minute. Okay. And for our geometry now, we want to just select this outer perimeter here, not the inside one. So be careful. There we go. All right, so that's good. Let's come on over to our passes tab. We're going to use an optimal load of 0.1 so that about 20% of our tool is engaged with the material here. And our stock to leave, we're going to leave a huge chunk of stock around the sides here of radial stock. So we're going to set that to 0.2. And the reason why is because we just want to remove those corners, okay? So axial stock, we want to bring it all the way down to the bottom. So we're going to set that to 0. So by setting it to 0, our tool will come all the way down to the top of our part. All right, we're going to check smoothing. Should be good to go. Let's go ahead and look at our tool path. Okay, so it should look something hopefully like this. All right, I'm going to simulate it here, and I want you guys to do the same. So check stock, make sure you see it. And so I'm going to speed it up or slow it down. My computer's running a little slow today. So looks pretty good. So we've successfully sort of removed those corners. All right, and another reason that it's good to use your 1/2" rather than a face mill is if we break a tool, it's much better if we crash or break a tool if it's just a 1/2" end mill versus a whole face mill. Okay, so I'm going to close this. All right, time to move on to our last operation. And now that we've successfully removed the corners, we can start our facing operation. So we're going to select a different tool, as you probably know. We're going to select that 3" face mill again. Go ahead and hit select. Our coolant, go ahead and set it to flood. And for our spindle speed, let's go with 4,000. And for our feed rate, let's go ahead and use 30. Okay, and for our geometry tab, we're going to just select our outer perimeter of our medallion again. And then in our passes tab, okay, we are going to, let's see here, we're going to use a pass extension here now of 1.5 inches. We're going to use a stock offset of just 0.1. And our step over is fine. We need to remove a couple layers here. So we're going to check multiple depths, okay, because you can't just come through and remove all that material with one pass. It's a pretty thick pass, so we need to do multiple passes here and multiple layers of cutting. So we're going to check multiple depths, and we're going to use a maximum step down of 0.05, okay? And everything else should be okay. Let's go ahead and hit okay. And if you did everything right, you should hopefully end up with a tool path that looks something like this. Okay, now let's go ahead and simulate it, and you should be doing the same. Okay, make sure you check stock. Okay. All right, so let's go ahead and play it. Okay, so our facing operation is going to come through, remove that. And it looks good. All right. Oh, one more thing to check, please, is check your setup 2 statistics, and hopefully you have something of around 3 minutes there for your second setup, okay? That should do it for our Medallion project. Remember, this is the beta version, so things may change or new videos may be uploaded. But thanks for watching, and we'll see you next time.